This discussion is going to be on units of measurement. We're going to start by talking about general units of measurement, and we'll talk about conversions later. So this is just a funny sign that's a real sign. I don't know if it was meant to be a joke at the time, probably, but it's just a sign that iterates how important units are. So you can see that the population and number of feet above sea level and the year it was established is not really, those units are not congruent, and therefore you can't just add them together. But I thought that was a funny sign to show how important units are. There are several SI units, so System International. Those are the standard sort of metric units that we use that are established as the standard unit of measurement for different quantities. And so you can see a list here of all of the standard measurements: mass, length, temperature. Amount is in moles, time is in seconds, current, and then luminous intensity we won't really talk about much in this class. So the first, let's see, mass, length, temperature, and amount, and time. We will talk about all 5 of those in this class. Current we will discuss very briefly second semester. So here's our table again, and the only point I want to make here is that you need to use these units that are written here. You have to use the correct abbreviation for these. So kilogram is kg, meter is m. Now later in this semester we're going to be using units that you may be familiar with if you took high school chemistry, and those are moles. Moles are abbreviated MOL. You cannot use the abbreviation M. The reason you can't use the abbreviation M is because M is already an abbreviation for something else. It's the abbreviation for meters. So here's our problem. We're going to convert 4.90 grams into pounds. We're going to start by looking up what we know about how to convert these two. This is our conversion factor. 1 pound is the same as 453.592 grams. I'll put that in the box. That comes from a table that would be given to you in the problem, so you don't have to remember that. But it's a good idea to write it down. The only other thing that we're given in the problem is this number 4.90, which we're going to write down. And then next to that, we're going to put our conversion. So if 1 pound is the same as 453.592 grams, then you will use that as your conversion factor. The reason I put grams on the bottom is because I want grams to cancel. So grams on top cancels with grams on the bottom, and we end up getting this number, 0.01080266 pounds. Now if we think about significant figures, there are 3 significant figures in that number that's given. There are 6 significant figures in the conversion. The 1 pound is an exact number. So that means that our number is going to reduce to 3 significant digits, which means that 8 that I underlined is the least significant digit. So we're going to round it to that. And that is our answer. All right, now we're going to look at a length conversion. So you can see a portion of a ruler at the bottom with inches on the bottom and centimeters on the top. Each of the lines is of course a millimeter on the top. So let's do a length conversion. How many centimeters are in 0.095 yards? So here is our conversion. How many centimeters are in 0.095 yards? I'm going to start by thinking about what we know. We know that there are 2.54 centimeters in 1 inch. That is an exact number. We also know that we can convert yards into feet and feet into inches. So we're going to start, this is a multiple step conversion. We're going to start by writing down what we know, which is 0.095 yards, and I'm going to start by converting that into feet because I have to ultimately get it into inches before I can convert it into centimeters. So there are 3 feet in 1 yard, and there are 12 inches in 1 foot. So if I put yards on the bottom, that will cancel, and then if I put feet on the bottom, that will cancel. And then I'll do the last conversion. 2.54 centimeters in 1 inch is my last conversion factor. And so you can see here that I have 1, 2, 3 different steps in my conversion. I'm doing them all in one line. You're welcome to do them in 3 separate steps. That would take a little bit longer, but if it makes more sense to you, it might be worth it. And you end up getting 8.6868 centimeters. Now, if we think about significant digits, the number that we're given, 0.095, has just 2. 3 feet in 1 yard is an exact number. They're exactly 3 feet in 1 yard. They're also exactly 12 inches in 1 foot. And it's kind of unusual, but the conversion from centimeters to inches has been defined as an exact number. So that those 3 significant figures will not limit your sig figs. So that means that our answer needs to be rounded to just 2 sig figs, which matches the number that we're given. And so we need 8.7 centimeters is our final answer. And last but not least, we're going to talk about temperature. We'll talk about how the 3 temperature scales are related, and then we will do a conversion from one temperature to another. So we're going to compare the 3 different temperature scales. The one on the left is the Fahrenheit scale, which of course is the one that we traditionally use in our country to define temperature. The one in the middle, the Celsius or centigrade scale, is the one that we traditionally use in scientific applications. And on the right-hand side is the Kelvin scale, which is the absolute temperature scale, which we often use in scientific applications, particularly for ideal gas law kinds of calculations, and for others as well, that we'll talk about soon enough. The Fahrenheit scale, the one on the left, if you notice that the 2 dashed lines are there to represent the boiling point and the freezing point of water. That way we can compare the 3 scales more easily by having the same relative point of comparison. The Fahrenheit scale was originally established back in the 1700s, 1720 something, by a guy named Fahrenheit, Daniel Gabriel Fahrenheit. He created this scale because 0 degrees on the Fahrenheit scale is the freezing point of brine. So when you mix equal parts of salt and ice, you get brine, and that has a freezing point of 0 degrees Fahrenheit. There was another temperature on his scale that I think he established as human body temperature. So there you go. Now you know what you need to know about the Fahrenheit scale. So I think that's what I wrote here. 0 degrees Fahrenheit is the freezing point of brine. And of course, 0 degrees, the Celsius scale, is the freezing point of water. That's what the Celsius scale is based on. And of course, the lower dashed line is the freezing point of water for each scale. And then this green line that I'm drawing here is the boiling point of water on each scale. That's so that we can compare them easily. Now, the difference between the boiling point and the freezing point of water on the Fahrenheit scale is 212 minus 32, which is 180 degrees Fahrenheit. And of course, the difference on the Celsius scale is just 100 degrees Celsius. That's what it's based on. It's also why it's called centigrade. So one thing that's kind of important to note is that I'm drawing a whole bunch of little graduations here on the Fahrenheit scale because there are 180 degrees in the Fahrenheit scale for every 100 degrees in the Celsius scale. So that means that the Fahrenheit graduations are smaller, right? They're tinier, they're a smaller difference because you can fit 180 of them in the same space that the 100 fit for the centigrade or Celsius scale. That's where this difference comes from. That's where this ratio of 5/9 comes from, is because on the centigrade scale it's 100, and on the Fahrenheit scale it's 180. So that is a ratio of 5/9, which in our conversion from Fahrenheit to Celsius or Celsius to Fahrenheit, there is a difference of 5/9 or 9/5 for each of those. So degrees Fahrenheit is smaller. Degrees Fahrenheit is smaller, 5/9 the size. because 180 degrees Fahrenheit fit in the space of 100. So now let's do this calculation. We're going to convert normal human body temperature in degrees Fahrenheit, which is 98.6 degrees. We're going to convert that into Celsius, and then we're going to convert it into Kelvin as well. So that's just a restatement of the problem at the top. Those are the two formulae to convert from either from degrees Fahrenheit to degrees Celsius on the left or from degrees Celsius to degrees Fahrenheit on the right. So you can see the 5/9 and the 9/5 in there. The subtraction and addition of 32 is to bring them both to the same temperature, because remember, Fahrenheit, the temperature scale starts 32 degrees above, if we want to put them on the same relative scale compared to the freezing point of water. So we're going to use the formula on the left, and we're going to plug in 98.6 degrees, and we're going to subtract 32 from that. That'll be the first. That gives us 66.6 degrees. We're going to multiply that number by 5, and that will give us 37.0 degrees Celsius. Now, significant figures are the only really challenging part of this problem, and so the significant figures come into play. The 32 is an exact number, so the 98.6, that is the addition-subtraction rule. When you subtract 32.0000000 on and on forever from that number, you get 66.6, accurate to the tenths place, that 0.6. And then you multiply 66.6 by 5/9, that's the multiplication division rule, and 66.6 has 3 significant digits, which is why 37.0 degrees has 3 significant digits. Now, if we take 37.0 degrees Celsius and we convert that into Kelvin, which is the second half of the problem, we're going to add 273.15 Kelvin to get the temperature in Kelvin. And we're going to take 37.0 and add that to 273.15. That gives us 310.15. And we need to round it to the tenths place, because the number 37.0 is not accurate to the hundredths place. It is only accurate to the tenths place. So we end up with 110.2, and that is the addition-subtraction sig fig rule. Now this is table 0.2 from your book, and this lists all of the prefixes starting with tera. Most of us are familiar with tera because of terabytes these days, and gigabytes and megabytes and kilobytes. And then all the way down to much, much smaller units, so units that are below the base unit. Deci is a tenth of a unit, centi is 1/100th of a unit, milli is 1/1000th of a unit, all the way down to femto is just about the smallest one that we ever tend to deal with. And so the ones up here in green, these are larger than the base unit. And then, of course, these ones down in blue are smaller than the base units. The base unit's right there in the middle. And there are some of these that you need to know and some of them that I don't know. So you'll need to memorize the ones that I've highlighted here with the red dashed line, kilo, and then all of the ones that are smaller than the base unit. Now I'm going to talk about how I think it's easiest to memorize these. You can memorize them however you want, but my advice would be to choose one way and stick to that way for now and evermore, or else you'll get confused and you'll start mixing up units. Okay? So what I would suggest, this is a table that I generated from the same table. The prefix is on the left. You also need to know the symbol. The third column is the conversion from the textbook. So 1 kilogram is 1,000 grams. As opposed to 1 milligram, which is the fourth one down, is 0.001 gram. I prefer big numbers and not small numbers, and so the one I prefer is in the last column, the fourth column. So there are 1,000 grams in 1 kilogram, but if you move down 4, there are 1,000 milligrams in 1 gram. And so that's the same thing as saying that there is 1/1000th of a gram in 1 milligram, but I just prefer the larger numbers. Okay, so what I would suggest is getting flashcards and begin memorizing these. These are the ones you need to know. So on one side of your flashcard you need to write the prefix, micro. Wouldn't hurt to know the abbreviation for that as well, is that mu, which looks like kind of like a U, but it's not. And then on the other side of your flashcard you need to memorize that 1 times 10 to the 6th micrometers or micrometers is the same as 1 meter. So let's do a conversion just to make sure everybody knows how So we're going to perform this conversion from milligrams to kilograms. And of course, this is a metric conversion. So we have to remember our prefixes and what those mean. So we're going to write down the only number we're given, which is 678 milligrams. And then we're going to try to remember our conversion factors, which are shown here. Doesn't really matter which ones you remember, but you need to know two of them on here. You need to know milli and kilo. So milli is here. So we're going to convert from milligrams to grams first. So 1,000 milligrams in a gram. Or 0.001 gram in 1 milligram. Either one of those are fine to remember. I like bigger numbers, so I'll do this one. So 1,000 milligrams, the milligrams cancel. If you choose the other way, you would set it up this way, where the grams goes on top, milligrams goes on the bottom. You should end up getting the same exact answer. It doesn't really matter which way you do it. It just depends on which way you prefer. Now we need to go all the way to kilograms. This is just to show you that these are the same. We're going all the way to kilograms, which means we need to know the conversion factor for kilograms as well. So if we go back to our table, 1 kilogram is the same as 1,000 grams. So we're going to take our 0.678 grams. We're going to divide that by 1,000. We're going to put the grams on the bottom so it cancels. And that's going to end up giving us 0.000678 kilograms, which is the same thing as 6.78 times 10 to the minus 4. And those units are kilograms. And that's my final answer. I started out with a number with 3 significant figures, and I end up with a number with 3 significant figures. None of my conversion factors should change my sig figs because they are all exact. Finally, the last thing we're going to talk about are derived units of measurement. These are units that are derived from other units. So the typical base units like mass, grams, length, meters, or time, seconds, those are all considered base units of measurement. But sometimes other units of measurement, for example area, are derived from these base units. And so, for example, area is length squared, right? And that's something that I'm sure you learned about back in probably elementary school, okay? Certainly middle school. Volume is a cubic length unit, and so even the volume units that we're used to using in everyday life, like gallons or liters, those are based on cubic length units as well. So we're going to also talk about density a little bit later, which is mass per unit volume. And so it's important first that we understand. So volume is derived from length. It is a length cubed. So this is an image from your book where the left box, which is green, is 1 meter on each side, which makes it a volume of 1 cubic meter altogether. If we divide each of those sides into 10 equal segments, then that would be a decimeter for each one. Those would be the little, that would be like the little blue box that you see in the upper right hand corner of the green cube. And if we pull that out and look at it, then you can see that 1 meter contains 10 decimeters, but 1 cubic meter actually contains 1,000 cubic decimeters, right? So how many decimeters are in a meter? There are 10. But there are 1,000 cubic decimeters in a cubic meter. And so you should, I think, pretty easily see that if you just take the side and divide it into decimeters, you get 10. But the entire box, you get 1,000 little blue boxes inside the big green box, right? So if you have 10 and you count all the way down, you get 100. And then if you count all the way back, 100 times 10, 10 times would be 1,000, right? So now the same thing would be true if you go from a decimeter, a decimeter to a centimeter, or a cubic decimeter to a cubic centimeter. And then if you combine those two and you think about how many cubic centimeters there are in 1 cubic meter, then there are 100 centimeters in a meter, but there are actually 100 cubed, or 1 million cubic centimeters in 1 cubic meter. Okay? So those would be how many little red boxes are there inside the giant green box, right? There's a lot. So let's do one last conversion. We're going to convert cubic yards into milliliters. This involves several steps, so let's do that now. So this is just to reiterate what I said verbally a minute ago. If we think about how many decimeters are in a meter, we know that's 10. But if we think about how many cubic decimeters are in a cubic meter, you can see that's the little red box. And so that's certainly not 10. We said that that's 10 times 10 times 10, which is 1,000, right? Way more than 10. Way, way, way more than 10. So whenever you cube the unit, you have to also cube the number. That's really important. You're going to make this mistake over and over and over again. So there are 1,000 cubic decimeters in 1 cubic meter. And I'm harping on it because I know you're going to miss it. So try to remember, when anything is done to the unit, it is also done to the number. So we're going to do this conversion last. This will be the very last thing in this section. We're going to start with 0.000951 cubic yards, and we're going to think about how many steps. There's a lot of steps to go from cubic yards to milliliters, and maybe you don't know exactly what step you're going to do first. But think about what you know. We know that a milliliter is the same thing as 1 cubic centimeter. That's one thing that we know. So if we can get cubic yards into cubic centimeters, we're going to be good. We know that 1 yard is 3 feet. We know that there are 12 inches in 1 foot. We know that there are 2.54 centimeters in 1 inch. We also know that if we just need to cube the unit, we need to cube the number that goes with it. So we're going to cube everything. Everything gets cubed. So that means that these are our conversions that we care about. You can always do the conversion yourself. You know, 12 cubed is 12 times 12, which is 144, times another 12 is whatever that is. You can do that yourself, or you can just write down 12 cubed, you know, and do it on your calculator that way. Either one works. I usually just put it in my calculator as I go, so I don't have to do the individual steps. So cubic yards cancels, cubic feet cancels, and cubic inches cancels. And that's going to give me my final number here. 1 milliliter is the same thing as 1 cubic centimeter. You can either show that step or not. I suggest if it confuses you that you show it, and if it doesn't confuse you, you don't show it. So 3 cubed is 27, 12 cubed is 1,728, 2.54 cubed is 16.387064. You can either do those calculations, or like I said, just plug them into your calculator as you do the whole calculation. That's usually what I do. And then the final answer here is 727.091669, which of course has way too many significant digits. So we'll have to deal with that. So the significant digits in the number that we're given has 3. The number 3 feet in 1 yard is an exact number. The 12 inches in 1 foot is an exact number, and the 2.54 number is an exact number. All of these conversions are exact, which means that our final answer needs to be rounded to 3 sig figs, which is the number in the original number that we're given. Okay, so we need 727 milliliters, and that is my final answer. And that's going to be the last calculation we do.